Okay, we have the equation y minus 4 over x minus 2 equals 1/2, and we want to solve this equation for y. Now, one thing that people don't seem to lock in their algebra courses is that if you have denominators in an equation, you can multiply both sides by a common denominator and get rid of those denominators. Now, you have to be a little bit careful because if one of the denominators happens to be 0, that's no longer a valid thing to do. But we're not even going to worry about that right now. We're just going to worry about how do you multiply both sides of this equation by a common denominator. Now, in doing this, there is an operation that people are taught to do by cancellation, but people cancel incorrectly. The majority of students coming out of our pre-calculus classes cancel incorrectly. We see it all the time when we evaluate these courses. It doesn't matter if it's our on-campus courses or courses from the high schools. And high school teachers that teach these courses, qualified high school teachers with master's work in mathematics, tell us that that's what happens in Algebra 2. Now, Algebra 2 is taught to the SOL, okay? So you do a lot of things that are expedient that don't build real understanding, just so people can learn to circle the right answer. So that's one of the problems with Algebra 2. Another problem is that students just aren't willing to do the work to learn the course. And teachers tell me that almost universally. Teachers, they're teaching select groups of high school students, or those of us who teach students who come to us with appropriate coursework and appropriate performance on placement tests, don't have a clue about what cancellation means. Many do, but we can't expect it. Half the class will cancel incorrectly. Another thing that people do is they learn to cross-multiply when you have a case like this. So you get 2 times this equals x minus 2 times this, okay? That's okay, sort of, if you apply it correctly, but it's just a shortcut for something that has a foundation in the rules of algebra. Cross-multiplication is not a rule of algebra, it's a convenience, as is cancellation, if you can do it right. And people cross-multiply wrong, not as often as they cancel wrong, but they do cross-multiply incorrectly. So I'm not going to talk about either of those. We're going to talk about how you do this using the rules of algebra. So we multiply both sides here by a common denominator, and that's going to have the effect of removing all denominators from the equation, making it very easy to solve. Okay? That clears our denominators, and that's a concept that should be firmly established by the end of an Algebra 2 course, or by the middle of an Algebra 2 course, preferably in an Algebra 1 course. So how does that work? Well, we find a common denominator. Now, from the work that we did early in the semester in this MCR course, we saw how to do common denominators of fractions. And that's what we actually started off with, because I know that fractions are not understood very well in our curriculum. For reason probably related to overuse of calculators. But again, our experience is students are not very competent with fractions and need to become so. You need to do this. So there are denominators. Okay, so the common denominator is the denominator that contains this as a factor and this as a factor. That's the denominator 2 times x minus 2. You know that you can always get a common denominator by multiplying your denominators, okay? So this is a common denominator. It's also the least common denominator, because you can't remove any part of this or any part of this and still have a common denominator. So we're going to multiply both sides by 2 multiplied by the quantity x minus 2. How do we do that? Well, we write down 2 times x minus 2 multiplied by this equals 2 times x minus 2 multiplied by this. And that's what I've done here. Here's this. Here's the left-hand side, here's the right-hand side, and in each case we have 2 multiplied by quantity x minus 2 multiplied by that side. Okay? Now, over here, we can rearrange these factors to read x minus 2 divided by x minus 2, and then that's multiplied by 2, there's our 2, times the quantity y minus 4. So every term here, every factor here is represented in this rearranged expression. Now why would we do that? Well, it's because x minus 2 divided by x minus 2 is 1. Dividing a quantity by itself, we get 1. And 1 times what we have here is just this. We don't have to write 1 times. Okay? And we understand that because 1 times anything is that thing. Over on this side, we rearrange it so we've got 2 divided by 2. And then that's times our x minus 2. Gives us 1 times our x minus 2, which is just x minus 2. So from here to here, it's not a matter of crossing things out. It's not a matter of cancellation. It's a matter of rearranging everything so that this divides out and gives us 1, and this divides out and gives us 1. That's what cancellation is all about. And if we allow cancellation, if I talk about cancellation, you know what people are going to do? They're going to cross out this 2 and this 4. Okay? It's totally invalid, but people are going to do it. Or even worse, you know, they'll cross out this 2 with this 2 instead of what they really ought to do if they understood what cancellation is. Now, many people do understand it and understand the rules. I don't like using it at all. I want to see it done like this. Again, because improper cancellation is so universal. Not everybody does it, but the majority do cancellation wrong. Okay, and this is at the end of a pre-calculus course, much less at the end of an algebra course. Okay, our pre-calculus instructors are busy teaching pre-calculus. We can't go back and teach algebra 2. We need to rely on getting competent students out of algebra 2, or we need to supplement, which is what this MCR course is all about. Okay. Okay, anyhow, we get this. How do we solve this? Well, people are still having a little bit of trouble here. We've got a couple of choices. We could distribute the 2 through here, the multiplication by 2, and that's what we end up doing. Or we could multiply both sides by 1/2, and that would actually somehow be a little bit more efficient. But I'm going to choose to do the distributive law here. Okay, and I get 2y minus 8, and that's obvious, equals x minus 2. And then what do I do? Well, I take the 2x minus 8 this side and I add 8. And I take the x minus 2 here and I add 8. Now I have people that want to write this as 2y minus 8 equals x minus 2, and then put an 8 here equals 8 here, and then add them that way. That's okay, but I saw at least one instance where that led to massive confusion because of not quite understanding what everything really means. So I kind of prefer this, although I don't reject the other, but you've got to be careful no matter what you do. Okay, so I've written down this side and this side, here and here, and then I've appended plus 8 here and plus 8 here. Now, negative 8 plus 8 is 0. And I could have written out another step. I'd have 2y plus 0 here. But that's just 2y, so I kind of skipped that step. But you have to think that when you do this. You have to think about how the rules are working. Then x minus 2 plus 8, of course, that's x plus 6. So I get 2y equals x plus 6.
And the third
okay. Then what do I do? Well, I multiply both sides by 1/2. Because if I multiply 1/2 by 2, I get 1. And 1 times y is just y. Well, I multiply by 1/2 on this side, and that's going to give me y. I also have to multiply by 1/2 on this side. So I get this. Okay, 1/2 times the quantity x plus 6, distributive law tells me that's 1/2 x plus 3. And over here, of course, as we saw, it's 1 times y, which is just y. So y ends up being 1/2 x plus 3. And now we've solved this equation for y. And to anybody who's been through Algebra 1 and Algebra 2, this really ought to be automatic. and automatically correct. I find that it isn't, so I think everybody needs a little more practice with this, almost everybody. Okay, now we want to go on to the question of what's the x-intercept and what's the y-intercept of this function. So this is a function, y equals f of x equals 1/2 x plus 3, and we verify that f of 2 equals 4 just to make sure we've got the right function. And if we've done everything, we've got the right function, we've got the right slope, everything matches the original conditions. So we want to determine what's the x-intercept and what's the y-intercept. Well, talk about that next.